This video experiment is meant to be an analog of bubble-driven magma mixing. We have two magmas here, a high-density, low-viscosity basaltic magma and a low-density, high-viscosity andesitic magma represented by water and olive oil. I've already dropped the Alka-Seltzer tablet in, which is providing carbon dioxide gas, representing some sort of gas that is dissolving and being released into our magma. The gas could come from a decreased pressure, right, due to magma ascending or due to confining rocks failing, for example. It could be caused by exsolution due to cooling. As a liquid magma cools and becomes solid, a smaller amount of liquid has to hold the same amount of gas and thus becomes supersaturated and allows for the exsolution of carbon dioxide in this case. We could also have a mixing or juxtaposition of magma bodies could cause exsolution, as well as simply an introduction of a gas-rich melt, perhaps a pulse of magma, of fresh magma that has a lot of gas in it. You can see that the bubbles are ascending. It's a little cloudy, but are ascending, are coming up to our liquid interface between our two liquids here, water and olive oil, and are beginning to pass through the olive oil. As they do this, they're entraining water and actually bringing it up. You can start to see this filmy here. They're bringing up water and trapping it in the olive oil as a long filament. That filament stays in the olive oil. Any water that's brought up will eventually start to sink back down, but the liquid soap that I've mixed into the bottom of the water is foaming on top as evidence of this material being transported all the way from the bottom to the top where it foams. We're starting to get a bit more activity as these bubbles are picking up and are driving through the less dense olive oil and causing it to mix more and more. You can see we have several layers like in a volcano lamp that are moving up. That's our water, and olive oil moving down. You can see here a plume of olive oil is being forced down as water moves up. What this represents is obviously the physical mixing of magma due to gas exsolution, but also the chemical mixing. What we started with is two end members, our water and olive oil, and through this whole gradient we now have differing mixtures of the two. In an actual magma, the filaments left behind in our more viscous but less dense liquid would act as trails so that later bubbles could ascend up that little trail, that low viscosity area, and actually ascend faster through that column to release, and it becomes a positive feedback loop. Bubbles rising here and first force through this layer leave a little trail of this liquid, allowing further bubbles to follow that same trail and leading to further and further decrease in density. This can lead to a magma chamber overturning entirely if enough gas is exsolved. In this case, it hasn't overturned, but you can see our olive oil layer, which is about 250 to 300 milliliters, 50 milliliters total, has been mixed so that its presence in this column has gone down to about 150 milliliters, and that will begin to settle out now that the Alka-Seltzer has stopped exsolving gas. The foam up here from the soap could represent a high viscosity magma that, if it had reached a vent, would have resulted in an eruption. In this case, it did not. And now that we have no more gas, this will settle out. But as you can see, the bubbles were eventually able to overturn. Enough of the water that had reached here slipped back down that we got rapid physical mixing of this. Thank you.